Hi, good morning, students. We started yesterday about qualitative dependent variable models. So, yesterday we introduced the linear probability model, and the linear probability model was easy to estimate using Wallace method, and we discussed its serious demerit that it assumes a linear structure of the probability, and which is not realistic. And then we discussed yesterday that there are better models in the form of probit model, logit model, which are popularly used in econometric analysis of qualitative dependent variable, and these models we'll be discussing today. So basically the major difference between the LPM model which we discussed yesterday and the probit logit model which we are discussing today is the improvement in terms of the pattern of probability. So assume there is a normal distribution. So all of you are familiar with the normal distribution. This is a the bell shape symmetric distribution which you are familiar. Now if this is basically the normal distribution. Okay, so if I graph the cumulative distribution of the normal distribution, so then it may take this shape. So what I have done here, this is a cumulative probability. So say for example with respect to -5, maybe probability here is say 0.01. With respect to -4, okay, sorry, -5 is this side. Yeah, -5. With respect to -4, maybe the probability is say 0.2. So the cumulative for -4 will be 0.1 plus 0.2 to say 0.3. So this way this cumulative probability distribution related to a normal distribution is constructed, which is given in the green line. It takes basically, it's like a S shape, okay, and this is a non-linear structure. Compared to this, yesterday we had discussed a linear probability structure related to the LPM model. Now the advantage of using this a cumulative normal distribution normal distribution is here at lower values of x, assume these are the x values, -5, -4, -3, etc. At lower values of x, a increase in x leads to a smaller increase in the cumulative probability. Okay, similarly at the higher end, when it is approaching say 4, 5, etc., so here also every increase in x value leads to a smaller change in the cumulative probability. Whereas if you take in the middle, say somewhere around 1, 1, 0, -1, etc., here as the x value is increasing, the increase in cumulative probability is higher. Okay, and this is more realistic as we discussed yesterday in the example of say house buying decision of a home buying decision of a individual. We discussed for very rich people with increase in income by 1000 rupees will marginally change the probability of buying a house. Okay, similarly for lower end, for the poor people, even increase in income by 1000 may not lead to significant improvement in the probability of buying the house, whereas in the middle income group, every 1000 increase in income is likely to increase the probability of buying a house at a relatively higher level. So this phenomenon is captured by this type of curve. So we'll begin with a probit model. For probit model, the probability distribution is assumed to be normal. Okay, now little more thing we'll discuss before going to the mathematics of probit model. See here the assumption is, let us continue with the example of home buying decision of an individual. So the assumption is there is some imaginary index in the mind of the individual you can take in terms of utility or in terms of desire to buy a house, etc. So this desire to buy a house, okay, which is say denoted by some index I, this I is not visible, okay. It is for the econometrician or for the researcher, he is not able to see what is the I value or I star value for an individual. So if this I value is above the I star value, some threshold, then the individual is buying the house, and if the I value is less than I star value, the individual is not buying the house, okay. So the decision of whether to buy a house or not buy a house, buy an apartment or not buy an apartment, is basically captured through an imaginary index which is there in the mind of the individual, which as a researcher or as an investigator we are not able to observe, okay. Now this imaginary index is function of various variables like income and home, interest rate charged on home loan, etc. For simplicity, we will stick to one variable. Obviously, that can be expanded by adding other explanatory variables later on. So assuming there is a single variable which is influencing the this imaginary index of the individual, which drives him or her to buy a house or not, if it is exceeding a threshold, let us consider there is only one explanatory variable which is influencing that, and let that be the individual's income. So let I be that imaginary index in the mind of the individual. As income increases, so income is explanatory variable, this index also increases, okay. Now at a point of time where this I, which is keep on increasing with increase in income, when this I exceeds a particular threshold, which I denote as I star, then the individual is deciding to buy the house, okay. And until it is less than that I star, the individual is not buying the house. So this way the I is related to X. I is that imaginary index, I am repeating, X is income of the individual, okay. So this relation I can put in this way. This is our familiar LPM model which we discussed earlier, where YI was 1 for buying house, 0 otherwise, and this was a function of A0 plus A1 xi plus ui. In fact, we had other variables in the other day, but I am restricting to one variable for simplicity. So instead of yi, now I am expressing in terms of ii. This ii is a function of, this is equal to A0 plus A1 xi and ui, okay. Now this ii, when it is exceeding I star, at that time yi becomes 1. Yi is, we observe whether the person is buying a house or not buying a house. When the person is buying a house, we take yi, that is y corresponding to individual I, as 1. If our observed sample, our observation in the sample, that is this individual has not bought the house, so there yi is equal to 0, okay. So like before, yi is a binary variable, okay, which takes value 1 when the person is bought a house, that takes a value of 0 otherwise, okay. Sorry. Now this yi, whether the probability of yi is equal to 1, that is dependent on whether ii is greater than I star, okay. So this way we are linking yi to ii. So be clear, yi is an observation which is visible to us, which is 1 when individual has bought house, which is 0 when the individual has not bought house, okay. Now we are relating this to the imaginary index which is sitting inside the individual's mind, which we don't know, okay. And this ii, which is an imaginary index, when it is greater than I star, then yi is 1. When ii is less than I star, I is that imaginary index which I am referring to, at that time yi is equal to 0, okay. And this II is an increasing function of x in this example. Okay, so to make this thing simpler, we are assuming this way. This is a PI, that is probability of buying house. Its probability of YI is equal to 1 is equal to probability that II star is greater than 0. Okay, so this is, if I am expressing this equation a0 a1 x a0 plus a1 x I plus ui etc. in the matrix notation as ax plus u, so then here when II star is greater than 0, okay, and then see I was telling in terms of II being greater than I star. Okay, now for simplicity that I am translating to II star greater than 0. Instead of telling II star greater than II, putting it as greater than 0 will make things simpler. Okay, so probability that yi is equal to 1 is equal to probability that II star is equal to greater than 0. That means probability ax plus u greater than 0. So with mathematical manipulation, u greater than minus ax or u less than ax. So this way, this pi, which is probability yi is equal to 1, is a function of ax. Okay, now if this function is assumed to be normal, a normal distribution, okay, there is a standard normal distribution formula where zi is normally distributed. Okay, now what we are trying to do, see here pi is a function of z or function of I. Now what I am doing, I am taking an inverse function where II becomes a inverse function of pi. See, from this pi as a function of II, I am getting II as an inverse function of pi. That's fine. Okay, so once I am getting II as an inverse function of pi, and II we know as we have specified, II is a0 plus a1x plus u. Okay, now we can estimate this model, okay, where II is equal to a0 plus a1x plus u, and we will be applying maximum likelihood estimation technique for estimating this model. And of course nowadays all statistical software have this maximum likelihood procedure, and yesterday also we had briefly discussed about the concept of maximum likelihood techniques, where the likelihood of a particular sample coming from a particular population is calculated, then across these different populations it is assessed what is the maximum likelihood that this sample has come from a particular population. So this way the unknowns of a0, a1, variance etc. are estimated. Now the very important thing about the probit, logit model etc. As of now we are discussing probit model. Okay, probit model is that model where distribution is normal, as we assumed here. In the probit model as well as the logit model, interpretation of the coefficients, interpretation of the estimated value of the dependent variable is very difficult. See, in LPM model it was easy. In LPM model, A1, which is the coefficient of x, was interpreted as 1 unit increase in x leads to A1 units increase in the probability. Okay, so that was very simple. But here the estimation, the interpretation of A1 becomes complicated. But using our calculus, we can make it simpler. So basically our del p by del x is equal to del p over del I multiplied by del I over del x. So from this we get this part. The first term is f a0 plus a1x, and from this the second part is basically a1. So here we can take an example to explain this. If the probit model is estimated like this, where I is equal to 0.0166 plus 0.04846x. How to interpret the slope coefficient here? So for interpreting the slope coefficient, assume the x value is 6. Using x value of 6, we get f a0 plus a1x, putting all those values as f of minus 0.72485. Okay, so basically once you estimate this equation, putting the value here, see basically coefficient a0 is estimated, coefficient a1 is estimated, x we have the observation. So if x is 6, then putting those values, f is calculated, I mean this is basically z, right? F z is calculated this way. So now for the given value of z, okay, using the normal distribution table, we can get the normal density for z is equal to minus 0.72485 is equal to 0.3066. okay, so this 0.3066 is basically like this part, okay, f of a0 plus a1x. Now we know the value of a1, so if you multiply this value with the estimated a1 value, we'll get the slope coefficient as 0.01482. okay, so here this coefficient 0.01485 gives us the increase in probability. Here it is positive, so I'm telling increasing relationship, I mean positive relationship. So increase in x value by 1 unit leads to increase in probability of 0.01485 that the value of yi is equal to 1. So basically, to simplify, from these estimates we can say that, from the estimated result we can say that the probability of buying the house improves by 0.01485 when x variable increases by 1 unit. So if x is increased measured in thousands of rupees, so if x is increased by 1000 rupees, then from these estimated results we can infer that the probability of buying the house improves by 0.01485. okay, so as I told earlier, here interpretation is not direct. So basically directly a1 doesn't give you information about change in probability of buying house due to change in the explanatory variable, right? So in a complicated way, after estimating the f of that, then multiply by a1, we'll get the number which will suggest what will be the change in probability due to change in the explanatory value of the explanatory variable. Okay. Then similarly the fitted values also are not directly given here. Basically your estimated value from the model is that of I. Okay, because the regression is run on I as a function of a0 plus a1x plus u. Okay, so the estimated value is that of I, that is that imaginary index which the individual is having in the mind. But what we require is estimated probability of buying house. So once we get I, okay, we had got I as an inverse function of P. So then if you reverse it, you will get P as a function of I. Okay, so that way we will not get the estimated probability for a particular value of x directly. We can get it as the inverse function of I, given the mathematics of probit model what we discussed. In a similar way, in the logit model, it is assumed that the relation between the probability of change in probability of buying a house and the variable x is explained through a logistic distribution. Okay, so let me explain the mathematics here. So here the pi is basically treated as a function of say a0 plus a1x, and pi is basically the probability of buying a house. When yi is equal to 1, we denote that as pi. Okay, And yeah, now if the pi is assumed to take this functional form, where pi is 1 over 1 plus e to power negative within bracket a0 plus a1x. Okay, if this is the pi, okay, with mathematical manipulation, basically treating this term in the bracket, within the bracket, that is a0 plus a1x as say zi, we can put pi as 1 over 1 plus e to power minus zi. Okay, and again with mathematical manipulation we can simplify, we'll get pi as e to power zi over 1 plus e to power zi. It is simple mathematical manipulation. If you basically use the mathematics simplification, you will get this equation easily. Okay, so basically pi is now e to power zi over 1 plus e to power zi. If pi is this, what is 1 minus pi? I think I have done it down the mathematics here, where 1 minus pi is 1 minus e to power zi over 1 plus e to power zi, etc. So I am, after simplification, I am getting it as 1 over 1 plus e to power zi. So pi is e to power zi over 1 plus e to power zi. 1 minus pi is 1 over 1 plus whole over 1 plus e to power zi. If I take the ratio of pi and 1 over pi, okay, so pi whole over 1 minus pi value I take from here, and 1 minus pi value I take from here, then with simple mathematical manipulation I will get pi whole over 1 minus pi as e to power zi. Okay, now this is a logistic distribution. Okay, I'm sorry, basically the pi, the way pi is explained here, this is a basically logistic distribution. So now with simplification we are getting pi over 1 minus pi is e to power zi. Okay, now the question is if we are putting it directly in the form of zi, it will be easy for us to estimate, because zi we are assuming as a0 plus a1xi. Okay, so if we are undertaking logarithmic transformation of pi over 1 minus pi, then logarithm transformation of e to power minus zi becomes zi. So basically the logarithmic of pi over 1 minus pi is equal to zi, which is a0 plus a1xi. Okay, so this form, this complicated form, I can denote as Li, and I'll call it a logit function. Okay, so this logit function is basically Li is equal to a0 plus a1xi. Okay, so again the problem is here, perhaps we will not able to apply OLS, because if you see when pi is equal to 0, okay, 1 over the 0 over this is equal to 0, and ln 0 is undefined. Similarly, when pi is equal to 1, this is 1 over 1 minus 1 0, which is undefined. So to avoid those type of problems, we will be basically applying maximum likelihood process of estimation, and like Probit model, here we are applying maximum likelihood estimation technique, and that is available for available in many econometric softwares, which is commonly used. Like Probit model, here also we have a some complication in terms of interpretation of the coefficients, but still interpretation is easier as compared to Probit model. See here, if your Li, what Li is giving, Li is basically giving the log of odds. Okay, it is not giving probability, it is giving log of odds. So basically log of the probability of success over probability of failure. So assume the probability of success is say 0.75, okay, then probability of failure is 1 minus 0.75 is equal to 0.25. So the ratio of probability of success over probability of failure is 0.75 over 0.25, so is equal to 3, right? So the odds ratio is 3 here. Okay, so then the logit is basically log of 3, log of the odds ratio. So it is not directly giving the logit model after estimation, it not directly giving us the change in probability due to change in x, the change in probability of buying a house, that yi is equal to 1, how it improves, that we directly don't get. What we get is the change in log of odds, the change in the log of probability of success or probability of failure is given by that coefficient corresponding to the explanatory variable when the explanatory variable is changing by 1 unit. Okay, but still what we can do, still we can directly estimate the probability after we are estimating the zi, which is a0 plus a1 xi from here. Once I get the zi, I can put the values of zi here in this equation, that is that logistic distribution equation, where pi is equal to e to power zi over 1 plus e to power zi. So once I know the values of zi, I can place here and I can directly I can get the value of pi, but we are not getting directly. Okay, indirectly in another equation we can get. And basically, if for a particular value of x, if li is estimated to be positive, that implies that when the value of x is increasing, the probability of buying the house improves. Okay, so still it is basically the log of odds ratio. So the log of odds ratio improves. Okay, so from there indirectly we can derive that there is a improvement in the likelihood of buying the house. And if li can be estimated to be negative for certain values of x, so that implies that when x improves, the probability of buying the house declines. Okay, so this way we can interpret the estimated coefficients and estimated values of the dependent variable for the Probit model and logit model. There is a close connection between the Probit model and logit model. Basically, the logistic distribution is flatter compared to the normal distribution. So with the variance of the normal distribution, which we are assuming here with mean 0 and constant variance, so variance is 1, and in a similar case the variance of the logistic distribution related estimates will be 1.81. so basically the partial slope coefficients of the Probit model multiplied by 1.81 will give you the closely the partial estimates of the partial slope coefficients of the logit model. And we cannot apply R square to assess the goodness of fit of the Probit model logit model, because these are estimated using maximum likelihood techniques, and there is a likelihood ratio function which is basically used for assessing the goodness of fit. So in standard econometric software there are McFadden R square, many pseudo R squares measures are available, which are widely used for assessing the goodness of fit of an econometric model, which is estimated using a Probit model and logit model. Okay, so here we conclude our discussion on the qualitative dependent variable case, and I have used Gujarati Basic in Econometrics as the reference for this, and even the discussion in Ramu Ramanathan Introductory Econometrics with application is also very lucid and simple, so you can use this for these lectures. Then in the following lecture we will be discussing about the limited dependent variable case, where we will be using a Tobit model to estimate the limited dependent variable case. All the best. Thank you.